Welcome to the Geometry Nodes Beginners course. In this video I will talk about the Raycast function in the Blender Geometry Nodes editor. But at first I will answer the question, what is a raycast? And thus, what is a ray? So at first, a ray is basically a line. If you have here a point, let's call this A, and you have a line going from this point infinitely in one direction, this is a ray. And the raycast function in 3D is basically when you analyze certain attributes or properties of this ray. For example, if you have an object here, then you can measure the distance when it hits something. So you can either just measure this distance or you can calculate where it hits the object and then change something here mathematically. So that's basically raycast in 3D. You analyze a line and you analyze the hit of something or the not hit, because it's informal or helpful if you know what you hit, but of course it's also good to know what you don't hit. So if you hit here something and you don't hit here something, you know that somewhere here is an object, but it ends here. And when you cast enough rays, then you can basically define the shape of something you hit, for example. By the way, this is the method that ray tracing is calculated to calculate light and shadow and reflections and so on, with rays like here, which hit something or don't hit something or bounce off and so on. Alright, so let's start with opening the Geometry Nodes editor. And then I want to delete this, or let me just use a UV sphere because we will need that later for the raycast. Let me just move that here, and then I want to add another object, doesn't matter. And on this we want to have the Geometry Nodes editor. This will be our target for the explanation. So let's just add some geometry nodes here to the cube, and we can detach it basically from here. And let me just use a grid, which is basically a plane here. Let me enable the visibility of the wireframe, that you can see the geometry here. So at first I want to make this way bigger, let's say 4 by 4. And I want to have 10 by 10 grid points here. And then I want to rotate this thing that I can point it into this direction. To do this, I will use the transform node, and I want to check if the direction is correct. Let me rotate it here, -90, and then it will look with its correct side here to this sphere. Okay. So now I'm good to go. So now I want to use the Raycast node. You can just find it under Raycast. And it's a pretty big node with many things in it. So at first we need our target geometry, which is this sphere, which is this object here. Yeah, so the object I want to cast the rays on. So let me just drag this sphere in here and connect its geometry to the target geometry. I want to change this to relative because I moved its origin here, so then everything is calculated correctly. Then the attribute input is not important here. The source position isn't important yet. So basically, if you don't connect anything here, it's like this, as if you would have connected a position node to this source position, which is just every single point here. Yep, the position node is every single point on this grid here, which is every one of these points. Alright, and the ray direction is not z negative in this case. Here I want to cast it on the y-axis, and you can see that in the gizmo here, y positive. So I want to change this. You can see this x, y, z. So you have to put this to a positive value. I want to cast positive y direction here, like this. and the ray length is 100 meters, doesn't matter, 100 meters is pretty far, so it's alright. Okay, so the output here is basically what's calculated then. In my case, at first I want to use the hit distance to calculate something, because here I want to measure the distance from every point to this object. So what will happen is every point here, since my source position is every point, will shoot a ray to the sphere. And the outer ones, of course, too. So every single point will shoot a ray to the y direction and will calculate its position then, or the distance of the ray. And when this is done, I want to visualize this or by moving the points then. So let me use a set position like this. And here at first I want to use, for example, the hit position, which is the point on the sphere. So for example, if this point here casts a ray and hits something here, then this is the hit position. So what I could do now is I could override the position of the point here with its hit position. And by that, this point would move on here to the point where it hit the sphere. And when I do this, like that, you can see something already happened here. Maybe let's move this. So you can see here that it kind of gets projected to the sphere. Maybe let me increase the scale here a bit, like this. So my grid now gets basically projected onto the sphere, because every point, so the former points here, hit something, and then the points got moved. And by that, I basically projected this thing on the sphere. And you can see when I get close to the edge here, then these points don't hit anything and miss it. And by that, they don't get displayed here. So you can see that here. So they disappear because they don't hit anything. Maybe I could show you that by using a join geometry and then plug that also here, that you can see the grid before, like this. So here you can see the grid missing the sphere on this projection, and by that it doesn't get displayed there. So now I could show only the projected part, and the missed shots, the missed rays, I don't want to project to something, it just stays where it is. So to do that, let me just delete this. So when I want to do that, there is one pretty handy option here, because you have a isHit output, which is a boolean, so a yes or no, 0 or 1. And when you connect the isHit plug to the selection of the set position, you limit the point shifting here from here to here only to points where you hit something. So basically, if you hit something, then you get shifted by the set position. If you don't hit something, then you are not in the selection, and then you don't get shifted here. So when I do that here, and when I miss now something, you can see that these don't get moved by the set position, because they don't hit something. isHit means then 0, and 0 in the selection means no selection, don't execute this node with this point. Okay, so now we have a grid which only moves the points when they hit something, yeah, as a projection basically, like this. Okay, so since this is a bit boring, maybe let's continue with some text here instead of the sphere. So let me delete the sphere and add some text. And let me just type in hello. So, and maybe I want to extrude the text a little bit. And I want to have it in the center, like this. And extrude it a little bit, so like that. And then I want to move it in front of the grid, like this. So, And now let me exchange here the Raycast target to the hello here. And yeah, it hits something, but the resolution is pretty low. So let me just put this to 100, for example. So now I have 100 by 100 points here. And now you can see something. This is now basically something like a monitor or a display which shows the pixels of something it hit. So you can basically consider this like a monochrome monitor or something, yeah? And when I now rotate this target, for example, with double R, I have a free rotation tool, you can see that this is, yeah, actually like a little rendering or something, yeah? This is like you now build a pretty simple pixel style rendering engine here where you can read geometry data and display it on a two-dimensional display like on your computer screen. And when I rotate it here or move it, then you can see that you have something like a projection to the two-dimensional window here. Alright, so now you saw how cool a Raycast can be, so you can basically build your own little render engine or something like this, or render display. But let's step one step further, because we can add something like a perspective here too. Because currently we don't really have a perspective, because we only cast the rays horizontally to the object or to the void, and then we hit something or we don't hit something, which means it doesn't really matter, yeah? So if I'm positioning it like this a bit, here diagonally, the H is not really bigger or smaller than the O, because I'm just hitting here something horizontally or I'm not hitting something horizontally. So you don't have a perspective on this two-dimensional display here. But let's change that now, because we can actually calculate with a simple vector calculation the perspective or one perspective. Because if we would have something like a point here, like an empty, let me just add an empty object here, we could display or cast the rays to that point like this. And by that, we would have something like a perspective. Yeah, that things in the distance get smaller than they are when they're close. And this is our anchor point for all the ray directions. And then we would have something like a perspective. And then it's not horizontally anymore. And yeah, this is pretty simple to do that. It's basically only one single calculation, because when you want to calculate a vector between 2 points, you just subtract them. So let's say these are the A points and this is the point B. Then to get this vector here, we basically only have to subtract B minus A. And when we do that, we get this A B vector. And by this, you can calculate exactly this vector for every of these 1000 points here. So let's do that here in this case. Let me just go down. And what we have to do now is we want to change the ray direction here, because we want to override it. Because here currently it's just horizontal on the y-axis, but we want to override it. So to do that, I need the empty object, so the location of this basically. This was our B vector, and then we need all the A vectors, which is the position. So I'm going to catch that. This is the A, and as I showed you before, B minus A is then what we will need. So let's add a vector math, put this to subtract, and then connect the location on top and subtract the position, and then use this as the ray direction. And now you can see already here a bit of distortion. Maybe let me increase this grid for that on, let's say, 6 by 6, and maybe increase this here to 200 or something. So it's a bit more dense. All right. And maybe I want to now delete or disable the wireframe, then you can see it better, because otherwise it will be black because of the many lines there. So let's look at our projection now. Here now you can already see the projection with a perspective. So you can see here now, when I move my target, I have a projection with a perspective. Let me just move this a bit back maybe. So when I now rotate this, you can see that it has this perspective, and it's getting smaller in the distance. I could change the text here. Let me just do that, and then maybe something perspective. Then it's maybe a bit longer to see it. So now I'm having it here like this. And you can see now it got distorted. Yeah, it's not parallel anymore. It's getting smaller and bigger depending on the distance to the point or to the display here, basically. Yeah, like that. And now we got something like a perspective with our self-made render engine, or however you want to call it. Yeah, but now we actually built something. Yeah, and you can see that it getting the distance between the letters is getting smaller and smaller and so on. Yeah, so you now really have a perspective, and you can change it, of course. Yeah, the further you are away, the smaller this effect is. But when you're very close to the text, I mean, you can already see it here from the side. Yeah, so the further you're away, of course, the more parallel these lines are. And when you're very far, very close, then these lines become more like a cone. And of course, then the perspective here is more, good to see, like this. Yeah, so, and yeah, this is pretty cool actually. So you can do a lot of things with it. As you saw, you can project or snap surfaces to other surfaces by just shooting rays, and then calculate the new position or the distance and so on. And then you have your own shrink wrap modifier, basically. You can build your own shrink wrap modifier how you want it to be. Additionally, you can of course edit this here. I mean, in this case, everything gets projected until it hits the object, but you can of course change the set position, the new position here. For example, the offset, you could decrease the offset a bit, that it doesn't get projected that far, for example. Yeah, but that's just an example to play around with. But of course, this works better if you have this horizontally projection like this. Yeah, here, for example, you could increase the scale here. For example, here you could have an offset here to bring it further to the face here, to the front face. Alright, so this was the video about ray tracing or ray casting. I hope you learned a lot and are now motivated to play a bit around with this node. Yeah, so because it's very flexible, so you can use it in a lot of cases, as you can imagine, because it's handy in general to have some rays which calculate distances to other objects or whatever. And it can be used in procedural animation in many cases. That's all for this video. Thank you and see you at the next one.